Hello everyone. Today we are going to talk about cryptography. You might know about encryption and you might have heard of it, but before talking about that type of digital encryption, we have to know where all of this encryption first came from. So let's go back in time a bit. Long back, there was a method of encryption which was called steganalysis. And using the steganalysis method, kings would send messages to other kings, and in this type of encryption, the message was written on a tablet, and the tablet was then covered with wax, and the person who receives the message has to remove the wax to read the message. But as you could guess, this type of encryption has a problem, because if anyone who is intercepting, or anyone who is the message is not anyone who is not supposed to see the message sees the tablet, it is pretty easy for him to just uncover the message just like the receiver would. So a bit more later, there was another form of encryption that developed. This was called transposition ciphers. And in transposition ciphers, a piece of cloth was wound around a piece of log, and the message was written vertically on the piece of cloth, so that when you unroll the cloth and spread it out, the letters would seem all jumbled up, and the receiver would have to then tie the cloth around a log of the same width to know what the message is. Now this is much more secure, because any interceptor won't just know how to decrypt the message. But the problem with this is it is also hard for the receiver to figure out the message, because the log could be of any width. A bit more time passes and encryption keeps evolving. Now it is the time of Julius Caesar, the emperor. He was known to use a cipher called, now it is called Caesar cipher. Using the Caesar cipher, the letters of the alphabet is shifted using a key. For example, if the key was 2, then A would become C, B would become D, and so on. So using this, the message could be encrypted and it wouldn't make sense to any readers, and the receiver would have to then subtract the key from the alphabets to decrypt the message. This is also around the time when Islamic scholars came into the field of cryptography. They were studying Hadith and Quran, and eventually they started to get interest in cryptography. And this is how an Islamic scholar found out something called frequency analysis that could be used to break the Caesar cipher. What frequency analysis is that you look at the encrypted message and find out the frequency of each of the letters, and this frequency can be matched with the frequency in the normal alphabets, and this could be used to replace the encrypted letters. So to trip up any code breakers, there were some methods that encryptors used. Some of those were null values, in which random symbols were inserted into the message so that they don't actually have any meaning, but it's just there to confuse any code breakers. There was also the method of using codes, in which some words had a meaning that both of the sending and receiving parties know about, so that even if the message is decrypted, it will not make much sense to the decryptor. But the problem is, a good code breaker could still decrypt the message pretty easily, and the code words could be made sense of using context. So this is where Vigenère comes in. Vigenère was a cryptographer, and he made a cipher that was much better. This cipher was immune to frequency analysis, and it was much more secure. But the problem is that the Vigenère cipher was not accepted by other cryptographers of that time, because it was seen as too complicated. But later on, the Vigenère cipher got more accepted. And then after a bit, the Vigenère cipher was broken by Charles Babbage. Yes, Charles Babbage is the one who invented the first computer, and he was also the one who broke the Vigenère cipher. What he realized was that to break the Vigenère cipher, we just have to find the key. The key is used to encrypt the message using the Vigenère cipher. So he found out that if we know the key, then it is pretty easy to find out what the message was. So when we talk about keys, this is a perfect segue into the next section, that is our current state of encryption, that is digital encryption. I say this because keys are very important in digital encryption. Let's talk about this a bit more. Digital encryption. There are two types of digital encryption. The first one is symmetric encryption and the second one is asymmetric encryption. Symmetric encryption is the more simpler one, but also it is less secure. In symmetric encryption, the sender and receiver first share a key, a common key that both of them knows, and the sender first encrypts the message using this key and an algorithm. There are many algorithms for symmetric and asymmetric encryption, and the sender then encrypts the message using this key. And now this receiver can decrypt the message using the same key and the algorithm. But as you might guess, there is a problem with this, because anyone who knows the key can access the message. So this is where asymmetric encryption comes into play. In asymmetric encryption, there are two key pairs. So that means there are a total of 4 keys. Each person, the sender and receiver, have a public and private keys. The public keys, as you might guess, can be known to anyone. It is fine for everyone to know about it. But the private key is what each person has to keep very confidential. And this public and private keys are linked mathematically, but they cannot be derived from each other. So what I mean by this is that if you know the public key of someone, you cannot find out in any way the private key of the same person. So what happens during asymmetric encryption is that first the sender and receiver, they exchange their public keys. Now the sender encrypts his message using the receiver's public key. So now the message can only be decrypted by the receiver's private key, which only he has. As you can see, this is really safe. So if we'll stand back a bit, we can see that encryption has gone through a big process, and there is still a lot more to learn about encryption. Encryption, from being just wax to now being complicated mathematical models, it has gone through huge amounts of change. I hope you learned something today. Thank you.